Going to look at one specific type of chord today, and it actually ends up being quite an interesting result. So what's called the chord of contact. So let's define it first of all so we know what we're talking about. So again, standard parabola. Chord of contact is when you've got two tangents coming from an external point. So all you know are the coordinates of the external point. So we'll just call them x naught, y naught. We can draw in two tangents and they'll meet at 2 points, and we just give them random coordinates. We don't know what the coordinates are because we don't know the equation of the tangent. So same with Q. But the chord of contact is the chord that joins those 2 points of contact, hence the name. So PQ would become the chord of contact. So the question is, what is the equation of PQ? Now remember, the only information we know is the external point, x naught, y naught. So we should end up with an equation in terms of x naught, y naught. There'll be no parameters P and Q in it. There's a few steps. It's quite a long question to do from scratch. Parametrics. So if I do it using parametrics, well, the first thing I would do is find the equation of the chord. Again, I'm not going to spend time doing it next. As I say, to do this whole thing from scratch is quite long. But you'll remember back in a couple of lessons ago, we found the general equation of the chord was P plus QX minus 2y equals 2APQ. So we need to get that equation first. Then we'd go and find the equation of the tangents at the parameter. So we'd probably prove the first one at P and then say, well, therefore the one at Q is that particular equation. Then we'd solve them simultaneously to show that that external point, the one that we know the coordinates of, would have the parametrics AP plus Q, APQ. And that now gets a link between the parameters. Because what we can say is, but hang on, I know the coordinates of T. It's x naught, y naught. So therefore x naught must equal P plus Q, or A times P plus Q. So therefore I know the relationship between P and Q. I know that if I add them together I'd get x naught on A. And y naught, well, that's APQ. Okay, let's go back to the equation of the chord. Remember, we're trying to get an equation of that chord without any P's and Q's. But now we know P plus Q is x naught on A. So I can substitute that into P plus Q. And we've just said y naught is APQ. So I can substitute that in for APQ. I now have an equation of chord, and it doesn't matter that I don't know what the point P and Q is because there's no mention of those parameters in the answer. The only constants that I need to substitute in for is the focal length, A, and x naught, y naught, the coordinates of the external point. Now if I rearrange this, something really interesting happens. There's the equation of the chord of contact. Now this is the interesting bit. Well, at least I think it's interesting. X naught x equals 2a y naught plus y. That looks very similar to something. What was it?
X squared.
Yes. When we looked at the Cartesian approach to the tangent, it had that exact same equation. But hang on, how can a tangent have the same equation as a chord? Well, the difference, of course, with the tangent is x naught, y naught was a point on the parabola. So you didn't end up getting a chord, you just got the equation of the tangent. Whereas x naught, y naught is not on the parabola. So we don't end up with a tangent because it doesn't touch. But we end up with that chord of contact. But again, it mimics what the equation of the actual parabola looks like itself. So I've just mentioned the steps that you go through. As you can see, if you were to do from scratch all of those pieces, it would be a very long question indeed. On the reference sheet they give us in the HSC, it's another one of those ones they just quote. So it is okay to just use it and what have you. The only time we would go and prove it is if they specifically asked us to prove it. But as I say, it's unlikely they would ask us to do the whole thing from scratch because there's just so much work to do there. It'd be a lot of marks if you think about it. Okay. Well, let's come up with that same equation but using a Cartesian approach. And this is the one you're going to think is a bit dodgy. And that's what I was just talking about. The equation of the tangent, when we did it with Cartesian the other day, we came up with x1 equals 2ay plus y1. So I know PT has that equation. I also know that t lies on the line PT. So therefore, if I substitute in the coordinates of t, I must get a true statement. So the coordinates of t were x0, y0. Sub that in, so this must be true. x0 times x1 is 2a y0 plus y1. We know that to be true. Well, therefore, P must lie on a line which has this equation. Remember, a line would be a constant times x plus a constant times y is equal to a constant number. Now, okay, it's written in a funny format, but that's what I've got. I've got a constant times x. That constant is x0. I have a constant times y. In this case, 2a is the constant. And then equals a constant, well, 2a y0 is the other constant. That is the equation of a line. And if I substitute x1, y1 into it, I know it's true because of the line above. So therefore, P must satisfy that particular equation. Okay. I can do the same thing with QT. If I give Q coordinates x2, y2, then I could show the equation of the tangent is x2 equals 2ay plus y2. But T lies on this line as well. So I know x0, x2 is equal to 2a y0 plus y2. So that is a correct statement. But hang on, Q therefore lies on this particular line. x0 x plus 2a y0 plus y. Because I know that if I substitute Q in, I get a correct statement. Well, hang on. If P lies on that line and Q lies on that line, that must be the line PQ. So therefore, the chord of contact is there. Now, when people first see this way of doing it, as I say, people think it's a bit dodgy because it feels like you haven't done anything. Alright? And yes, okay, we haven't done a lot of maths compared with that first method, which would have a lot of maths involved. But what we're basically doing is using a bit of logic to go and solve the problem. Okay? I'll leave you with that thought. You might like to have a go at that in some of these questions. So 9H, we'll have a few chord of contact questions.